Yes. Thank you, Vinod, and thank you to all the organizers for making this possible, Brian and everyone. Of course, I want to talk here about numerical solutions of differential equations using free software from the perspective of a university instructor who has the same, I imagine most people here are math teachers in some form or other. And I want to talk about my own experiences in the hopes that they may be helpful to the audience. And hopefully at the end, there's a couple moments for others to share their own experiences, because I don't know everything. So first of all, question of what is free software? This is, some of you may know about this issue and others may not. It's really kind of a can of worms, what free software is. Probably most lay people just think it's software that doesn't cost anything. But if you used it in that way, then a lot of people would be truly upset with you because it can also be used in a very different sense. If you look up free software in Wikipedia, it says computer software distributed under terms that allow users to run the software for any purpose, as well as to study, change, and distribute it in any adapted versions. And that it's a matter of liberty, not price. All users are legally free to do what they want with their copies of free software, including profiting from them, regardless of how much is paid to obtain the program. So, as far as I'm aware, this movement originated from a fellow named Richard Stallman. He's not the only one. And he has this organization called the Free Software Foundation, started around 1985. And I associate free software with the Linux operating system, which I used to use a little bit. And I cannot tell you all the details of what all the legal and philosophical distinctions there are, but if you don't know about this, you may find it interesting to read up, because there's some very, very enthusiastic and passionate people. But for my purposes, and probably for most the purposes of most math instructors, it's not a question of free as in speech. Well, the Free Software Foundation would say free means freedom. As a math instructor, I'm just thinking, so they distinguish between free as in speech and free as in beer. For the purpose of this talk, we mostly care about free as in beer, free as in free of charge. In other words, free from having to pay money. So I just want something that is usable with my students. It did make me think what matters about free software as an instructor. And there's a few things that matter. And actually, the more free it is, the better. Of course, the number one issue is I want it to be something that my students can use. Some proprietary software is incredibly expensive. My college just doesn't want to pay for it. So it has to be something we can use it all. But another issue, my college, Springfield College, has a license for Mathematica software, a limited license, which I do teach with from time to time. But I find a lot of time and effort is wasted every term just going through the licensing setup, setting up all the students with the cloud. It will really take a half hour in class to walk people through it, and still some people won't get it. So if I found that, money aside, it's just a lot easier to have something where you start using it and no one asks you any questions. Another thing that's nice about free software, even if the college has a license, we want students to be able to use it in the classroom when we used to have classes in classrooms, or at home, or just anywhere. It should be convenient. Also, I feel better about spending my students' time on using software that they're going to be able to use beyond college. And so I'd rather have them use software that's free of charge, and therefore that everyone's going to be using outside. They won't need a license at all. As far as modifying source code, that's kind of cool, but most of my students are not at that level where they're experienced programmers, and we don't really so much care about that. As to free software for math, this talk is focused around a couple of examples from a couple of packages. So I really like Wolfram Alpha. It's really easy to use. Trial and error, I put this bullet point up, meaning that you can actually use Wolfram Alpha without necessarily having trained at all in it if you just use normal English language expressions to do something like take a derivative or solve an equation. In my experience, usually Wolfram Alpha will just know what you mean. And if it doesn't know what you mean the first time, then it'll probably know what you mean the second time, the third time if you use trial and error. So that's amazing. Just it's very carefree. You can just start using it. And Wolfram Alpha, in my own opinion, is highly functional. It's a cousin of Mathematica software, which is incredibly powerful and also really expensive. For the purposes of education, Wolfram Alpha will mostly do what we would want to do. My other favorite free software for math and differential equations is R. I'm not sure how many audience members know about it, but if you don't, I hope to give you a quick introduction. It's really wonderful. Programming language and free software. It's free in every sense of the word for statistical computing and graphics, supported by the R Foundation for Statistical Computing. And a beautiful thing about R is that programmers around the world contribute added packages to it, added functionality, and it is totally free of charge. Expanding, talking about R a bit more. It's rising in popularity. It's incredibly powerful for and useful for data science, which is obviously one of the very hottest fields today. Also for sports analytics, that happens to be an interest in mine. It's highly efficient with the computing resources it uses. Easy in most ways to run. It is, you do have to use the correct syntax. And I think it's really nice educationally in the sense that it teaches students about logic. They're more used to, if they're not computer science majors, they're more used to point and click for everything. And you do have to think a little bit from in a logical way. So I guess the discussion is really meant just for the end. For what it's worth, as I wrote there in purple, I don't pretend to be the world's leading expert. So if we have time at the end and other people can contribute their own packages they use, this could be a useful discussion. So more philosophizing, priorities in teaching. So it's really an interesting question I think about all the time, like why do we teach math? Our mathematics teaching originated from a time when there were no calculators, let alone computers. Now, most of our calculations can be done using computers. Why do we teach math? Everyone's going to have their own answers. Here are mine. Number one, I would say math problem solving skills, if taught intelligently, they should be transferable to other things, to anything in the workplace. So our math students, oh, I see some chats with some software packages. That's nice. Anyway, our math students hopefully will be highly valued by a number of employers in various fields because they're smart and capable and able to think logically. Another reason that we teach math, honestly, is certification. Even if our students are not going to be using calculus, it's great that they have learned calculus and they get their degree as perhaps as a mathematics major, and everyone knows that they're smart and capable. And then of course there's other reasons too, not that this is like an exhaustive list or anything. Point of all this though, bottom line, for me as a teacher, I'm not so much interested in a black box that solves differential equations. It's more about the process of learning and the process of solving and understanding. So looks like there's about 10 minutes only, including any question times. I want to go over a numerical solution of that particular differential equation in R. If time permits, do a little bit of Wolfram alpha work as well. I see in the chat people are mentioning Python with Anaconda, Sage with R, and Jupyter. There's certainly lots of stuff out there. Anyway, so we're at the end of this slideshow. Let me go ahead and share a different screen. Stop this, share, and new share. Where's my RStudio? Okay. All right, so I assume I can't see it down below, but I'm assuming that everyone can see my RStudio window and no one is shouting out. Oh, thank you, Vanessa. Okay. So let us, so we are solving the differential equation dx dt equals x times 1 minus x with initial condition of x of 0 equals 0.1. So let's go ahead and set our initial condition. And then we'll set up the time. We're going to have steps from 0 to 10 and steps of 0.5. I'll type time here. So these are the steps that we're going to use Euler's method, I should say, Euler's method to solve this differential equation. Let's enter in the function. Actually, I think I will make things a little bit faster and just insert code from my history window. So there is our function, and you can type f of 3 or something like that to make sure the function's working. Now we can initialize a vector x with our solution. And then we can insert, so we already defined the function f. We can now set up a for loop. And now, uh-oh, didn't work quite as planned. And exactly this code worked before. Let me well, it worked for me earlier. It worked for me earlier, and it gave. So I must have missed something. But anyway, it does work out. It gives the solution, and when you plot this, you can see my plot over here, and it gives a pretty accurate solution. So this is a nice way. This is a nice way of showing the students how to really understand Euler's method in a hands-on way, and yet without having to calculate all the steps one by one. Let me go ahead and show how to solve the same equation using a different package, Wolfram alpha. And I just love Wolfram alpha because it's so easy to use. Let me unshare. and reshare. All right, so you can do the same thing much faster here using Wolfram Alpha. I'm assuming everyone can see this Wolfram Alpha right now. Okay, good. So we just had to say Euler method, give the equation, the initial condition, the steps. This will show us not only the numerical solution, but the exact differential equation. It'll lay everything out nicely for us, exactly what its interpretation was, and then it'll even tell us about what happened using other methods. So I really like the numerical solutions for what it's worth. Of course, Wolfram Alpha can do more like black box solutions. Here's y prime prime plus y equals 0. You can see Wolfram Alpha solution of this. Give a general solution of this as constant times sine of x plus a constant times cosine. You can, of course, plug in initial conditions. I'm trying to copy and cut.
Andrew, you got a minute.
Okay. Oh, just 1 minute. Okay.
Yeah, 1 more minute.
All right. So let me just paste this and there's a solution with initial conditions, and I can stop there then.
All right.
So thank you.
Thank you, Andrew, for the wonderful presentation. Any questions for Andrew?
And I should say, if anyone has other, I'm happy to answer questions, or you can use their final minute to suggest your own packages that you think might be of interest to everyone.
I see lots of conversations in the chat window.
Yes, maybe that's the best place for it.
Yeah, that's what I'm looking at it. Someone said Jupyter is a web platform with Python and R, and there is lots of discussion with R right there. And someone suggests that Sage Math, they can do R within the Sage Math. Yeah, the conversations are going on in the chat. They can also unmute themselves.
Octave.
Yeah. If anybody want to share something, you can unmute yourself and talk about it. Any questions for Andrew or any suggestions, just like he said? Okay, Kate said she's using Octave. Any ideas on Octave and all those things? So yeah, I have a quick question, Andrew. So when you give a problem to the students, do you recommend them to use Wolfram Alpha or they have a choice to choose?
So when I teach differential equations, I would use both of them at different times, and I will also sometimes ask my students to solve problems with no technology at all, depending on the context of the problem.
Okay.
Yeah, so really it depends for myself.
Okay, so in a way, what I'm asking is, suppose if you say you use Wolfram Alpha and then the students use MATLAB, is that allowed, or do you specifically say you got to use Wolfram Alpha to solve it?
I probably actually wouldn't even, I wouldn't insist on Wolfram Alpha, but I might insist on lower levels of technology, as in do this problem with using nothing beyond a graphing calculator or nothing other than R.
Okay, thank you. So we also got something from Tom. he gave some references. Everybody, I would like you guys to direct to the chat. And he says the Sage and Octave or on Python can all be used on either platform. Yep. All right. If we don't have any questions, let's thank Andrew one more time for this excellent presentation.